Okay, welcome again, our viewers. Today we are doing differentiation. Remember, again we said we've done some revision on other topics, equation of straight line indices. So you can subscribe to our YouTube channel. It shall be on our page again in Facebook. Our Facebook, you can go to Robert Jero, you can follow, because the list of the friends is full. You can just follow, or you can just like our page. We are Teacher Jero Credible Foundation, or just like our YouTube, Teacher Jero Credible Foundation. You can just subscribe, like us, and follow us, so that we can be able to go together. We revise together, we help one another together. We say this is the time we require one another or the most. So today we shall be doing differentiation. We shall be doing differentiation, a topic in Form 4, which is a simple topic, a good topic, a topic that is so much examinable. So in most of the papers, KCSE papers, you will not miss a question on differentiation. And today we are going to do some few examples on the differentiation. And one of them is find the equation. Find the equation of the normal to the curve whose equation is x squared equals to 4y at point 6, 9. We are required to find the equation of a normal to a point. Remember, in Form 3, we've done something to do with the tangent. We've done something to do with the normal. So a tangent, we said it's a line that is that has the same gradient with the curve at that specific point. But for a normal, it's a line that is perpendicular to the curve or to the gradient of the curve at that particular point. Therefore, when we are talking about the normal, in this case, assuming the curve is just like that, we are talking about, this is the tangent, but this is the normal. And remember what is said about the relationship between a line and another line. For instance, if this one is the tangent and this is normal, the gradient between these two lines, when they are multiplied, they give you -1. That's one of the aspects we should remember about the normal and the tangent. Then in our case here, we are given a curve which we are required to find. We are supposed to use this equation to come up with the line of the normal, or the line that is perpendicular to the curve at this specific point. That is 6, 9, where the value of x is 6, the value of y is 9. Now our equation is x squared equals to 4y. We can write it as well as 4y equals to x squared. This equation we can remain with y on one side, and we shall have y equals to 1/4 x squared. Then from there, we differentiate this one. Gradient, remember, is equals to dy or dx over dx, or change in y over change in x. Therefore, this one, for us to find the gradient or change in y over change in x, we differentiate this equation. Therefore, you remember the rules of differentiation. So in our case, what we do? We multiply the power by the coefficient here, then we subtract 1. Remember, it is opposite with integration. So in our case here, we are having y is equal to 1/4 x squared. So we multiply 2 with the coefficient. We have 2, y equals to 2 1/4 x squared minus 1. Remember, we multiply the power, then we subtract 1. This one will give us half x. 2 minus 1, we get 1. Therefore, it is half x. Therefore, our gradient to the curve is equals to half x. Is equals to half x. But remember, we are talking at this particular point, this specific point, which is 6, 9. What is the value of x at this point, which is 6, 9? The value of x is equals to 6. and therefore our gradient will be equal to half 6, which is equals to 3. Therefore, the gradient of the normal, or the gradient of the curve, not the normal, but the gradient of the curve at this specific point is equals to 3. The gradient of the tangent, or a line that is tangent to the curve at that specific point, it is also 3. But the gradient for this normal now, the line of our interest, shall be equal to, we shall use the formula that we've been using before, m1 multiplied by m2 is equals to -1. Our m1 is 3, multiplied by m2 is equals to -1. Our m2 will be equal to, we divide by 3 this side, and the other side we divide by 3. So our second, the gradient to the normal will be equal to negative that. Remember, we have the point, we are given a point. Therefore, to find the equation of that line, we find another general point, which is x, y, and we have 0.69. Then we have the gradient, which is equals to negative that. Then how do we find the equation? The equation is change in y minus 9 over change in x, that is x minus 6. This one is equals to -1 over 3. We cross multiply, we get 3 into y minus 9 equals to -1 x minus 6. This one will give us 3y minus 27 is equals to -x plus 6. We can simplify further or leave it at that point. But if we want to simplify further, that we are left with y on one side, we shall have 3y equals to, we take 27 the other side, minus -x. We take 27, it was negative this side, the other side it will be positive. This one will give us plus 3. From there, if you want to be left with the equation in the form of y equals to mx plus c, you can prove that the gradient of the line is negative at that. And we can do that by dividing the equation all through by 3. We can divide the equation all through by 3, so that we have 3y equals to -x plus that 3. We divide by all through by 3, we are left with y equals to -x over 3 plus 11. And in this case, it is in form of y equals to mx plus c, and our m in this case is -1 over 3. We can prove that our gradient to the curve is -1 over 3. This is all about tangent and the lines to the curve. If a line is tangent to the curve, we said again the gradient is the same. It's just like when we were relating the gradient of parallel lines. But for a normal, it's like when we were talking about parallel and the perpendicular lines in form 2. But it's the same, it's one and the same thing, only that in this case now we are dealing with the curves, not lines. But to repeat again, if the tangent to the normal, if the tangent is, if a curve is tangent to another line, the gradient are the same at the point of tangent, or at the point at which the line is meeting the curve. At that point, the gradient is the same. But the gradient of a normal at that specific point, is equals, that is just like a gradient to a perpendicular line to the tangent. It's perpendicular line to a tangent. We can see another application of differentiation. This one is a little bit on a different area. And that one is a particle moves in a straight line from a fixed point. Its velocity, which is given by Vm per seconds after t sequence is given by v equals to 9t squared minus 6t plus 2, then calculate the distance traveled by the particle during the second. Therefore, we are required to find this. Here there is a particle that is moving at a certain speed. The speed we are already given, and we are told that the particle is moving at that speed. Then we are required to find the distance that particle covered during a certain second. And here it is the second. Here where it means that this particle, we are required to find the time. Remember, this particle was moving from time 0. It moved from time 0 to time 1 second, 2 seconds, 3 seconds, 40 seconds. Now at second, it means that this particle was moving from first second and the second. So we are required to find the distance that it covered from second 1 to the second. I know that the ones might be confusing. The first one we mean second, which is 2, but this one is the second. Yeah, we can understand it that way, but I hope we understand what we mean. It is that during this period, the first second, the second, the third second, during the second, what is the distance that this particle cover? Now, in our case here, so when we are given, this is, remember, there is a relationship between distance, velocity, that is speed, and time, and acceleration. You remember not time but acceleration. You remember the relationship between these three. If you want to find velocity given distance, we differentiate the equation of the distance. If you want to find the acceleration given velocity, we differentiate the velocity equation to find acceleration. And moving upward, if you want to find velocity given acceleration, we do integration. If you want to find distance given velocity, we do integration. Remember, integration is opposite on differentiation. That is why it is not so much difficult to include this one in our differentiation, but we shall cover it more in our integration. Integration is the opposite of differentiation. It's just like removing shoes and the socks. So you remove socks, you remove shoe first, then you remove the socks. But when wearing, you start the other way around. You wear socks, then you wear the shoe. Just the opposite one another. So differentiation is the opposite of integration. So we have no problem handling the two together. But in our case, we are given a velocity. So we are required to find the distance. That one tells us at this point we should do what? We should integrate, because we already have velocity. Remember, we said when given distance, to find velocity, you differentiate. When given velocity to find acceleration, we differentiate. But upward, when we have acceleration, we integrate to get velocity. When we have velocity, we integrate to get distance. In our case, we are told this is the velocity, which is the speed of the particle at the time t. Therefore, to find distance, we integrate the equation. 9t squared minus 6t plus 2. We integrate the equation as 9t squared minus 60 plus 2. And remember, we don't want to find the distance of the whole journey, or the whole distance that was covered by the particle from point 0 or from time 0 to infinity. We want to find the distance covered by the particle from distance t is 1 to t is 2. This distance, that period between first second and the second, that's what we are interested with. Therefore, we integrate that one, and our integration we shall get integration of the equation at from point 1 to point 2 shall be equal. Remember, in differentiation, we were just multiplying the coefficient with the power, then subtract 1 from the power. But in integration, we said we do the opposite. So instead of subtracting here, we add. Instead of multiplying here, we divide. But how do we go about it? Remember, in our differentiation, we were starting with the multiplication, then we subtract the power. But in integration, we do the other way around. Remember, we said here we add, here we divide. But the process also is opposite. Instead of starting with division, we start with addition. Remember, in differentiation, we are starting with the multiplication, then subtraction. In this case now, we add, then we divide. So in our case, we shall have, if we add 1 here, we shall get 9t power 3. So it shall be 9t power 3 divided by 3. We add 1, we divide by the resulting power, then we subtract 6, t power 1. When we add 1 here, we get 2, we divide by 2, plus, remember 2, when it's a constant like this one, you remember the 0 power rule, where we were saying if number is raised to power 0 is equals to 1. Therefore, these 2, we can write it as x power 0. Meaning that this one, it's 2x power 0, it's the same as 2, because x power 0 is 1. Therefore, this one can be 2. Therefore, a constant, 2, 3, 4, if you raise it to a variable raised to power 0, is the same as that constant. Therefore, 2 raised to power x 0 is the same as 2. So if we raise it to power 0, then we add power 1, we divide by 1, we shall have 2x power 1 divided by 1. Then the equation, the original equation, because we are integrating to find the original equation or the distant equation, remember it shall have now a constant, plus c, which is the constant, plus c, which is the constant. In our case now here we shall have integration of, now this one, dt with respect to t. With respect to, when we simplify this one, we shall have 9 divided by 3 is equals to 3 t 6. Now 6 divided by 2 is equals to 3 t squared plus 2x plus c from 1 to 2. From 1 to 2. Now, this is a distant. This is a distant. This is the equation for the distant. If we substitute these values to this equation, we shall get the distant at the specific point. Now, if we substitute with the 2, we get the distant at second. If we substitute with 1, we get the distant at first, second. In between there, we need to find the difference. It's, for example, if you are told to cover what the distance is covered between point A and the point B. Therefore, what we need to do is subtract A from B, so that you can get the distance in between. So what we do in our case, we substitute 2 to the equation and substitute 1 to the equation. So in our case, we shall have 3, our t is 2 now, which is 3 multiplied by 2 power 3 minus 3 2 squared plus 2 multiplied by 2 plus c. Remember, c is constant here. Now, all of these 1 minus. We subtract now the same equation, but now we substitute with 1, so that we can get the difference between the first, second, and the second. So in our case, all these 1, we are subtracting in bracket 3 t is 1 cubed minus 3, remember t is 1 squared, plus 2 1 plus c, the whole of this 1. We can simplify further. What is 3 multiplied by 2 power 3? 2 power 3 is 8. Multiplied by 3, it will give us 24. 24 minus 2 power 2 multiplied by 3 is equals to 12 minus 12 plus 4 plus C minus again, what is 3 multiplied by 1 power 3? This is the same, is equals to 3 minus 3 raised to 1 power 3 multiplied by 1 raised to power 2 is equals to 3 plus 2 plus C. Then from here, what is 24 minus 12? This is equals to 12 plus 4. That is 16 plus C minus 3 must 3 yes, 3 we get 0 plus 2, we get 2 plus C. So our final equation will be 16 plus C minus 2 plus C. No, this is negative. Sorry, this is why we said we need to be so much careful. Can see we are also making an error. It is negative multiplying by positive 2, we get negative 2. Negative multiplying by positive C, we get negative C. So that we get C minus C is equals to 0. 16 minus 2 is equals to 14. And therefore, our distance from point 1, from the first second to the second, it will be equal to 14 meters. It's equals to 14 meters. Therefore, it means from point 1 to point 2, that is from the first second to the second, this particle will have moved 14 meters. 14 meters. I think that one is enough for ourselves today. We can digest that one. You find another equation related to this one, related to our first example. Just try to go about it. If there's a problem, again, we said you can raise your concern through our Facebook forum, through our page in Facebook, through our YouTube. You can subscribe, like, and we shall be able to help one another. Remember, we said again, this is the time we need one another so much. And I remind you again, Corona is real. It's killing people. Let us remember to sanitize. Let us remember to wear our mask. I remind you again, we are at home. We are working at home. So we are not wearing a mask like a time like now. But remember, when you move to the public, when you go to congregation, when you are worshiping, when you are meeting with other people, when you're in the market, remember to wear the mask, because Corona is real, is killing people. Just remember to wear your mask, sanitize, and eat well for your health. And we shall overcome. We shall overcome. Together we shall overcome. So have a good night, and God bless you.